Thank you again for joining us today as we talk about 3 essential tools to improve performance optimization. My name is Kelly Bakelich. I'll be your host for today. So before we get started, just going to cover a couple of housekeeping items. First off, we will have a Q&A session with Austin at the end of the presentation. So if you're new to Zoom and would like to ask a question, just feel free to use the chat feature at the bottom of your screen, and I'll add that to the queue. Second, we are recording today's session, and I will send you a copy either later today or early tomorrow, so you can feel free to revisit this or share with your friends and colleagues. And lastly, if you're experiencing any technical issues, again, just feel free to use that chat feature and I will assist you as soon as possible. All right, now the fun really begins. I am very excited to introduce today's speaker, Austin Parker. Austin has been solving and maybe creating problems with computers and technology for most of his life. He is the principal developer advocate at Lightstep and maintainer on the open tracing and open telemetry projects. His professional dream is to build a world where we're able to create and run more reliable software. And in addition to that, his professional work, he's taught college courses, spoken about all things DevOps and distributed tracing, and even found time to start a podcast. So, and also, Austin is the co-author of Distributing Tracing in Practice, published by O'Reilly Media. So with that, I give you Austin Parker.
Hello. How's everyone doing today out there in the dang old internet? So, thank you for the introduction, Kelly. My name is Austin Parker, and today I'm going to talk about these 3 essential tools to improve performance optimization. Now, the great thing about talking to people online is I don't really know what you 100% expected when we're going to talk about this, but someone comes and tells you, like, we're going to talk about a bunch of tools. Mm, I think you might be surprised. So I want you to make sure you stick around till, because the tools that I'm going to tell you about are maybe a little different than the ones that you would think, based on your expectations. So with that in mind, let's start by asking a question. And that question is, what is performance? Right? Like, let's really kind of go back to first principles on this. It's not just benchmarking your software, right? I think we get caught in this trap as developers, as, ops people, as PMs, as whatever, and we think about performance in this very sort of linear way, something that can easily be measured and quantified. And it's really easy to kind of get caught in the trap of thinking that performance really is just profiling, right? And when I say profiling, I mean we're literally looking at how quickly can the computer execute commands we give it. Something like this, right? This is a call graph. There's a fun story behind this. I'll tell you in a second. But this is performance at a really raw level, right? This is looking at the call graph of the execution of a program, and we're literally saying, like, okay, over this period of time, over some measurement of linear time, what is taking time on the CPU? Because a computer can only do so many things at once, right? Really, it can only do one thing at once per core, and multi-threading and other technologies are ways to sort of elide this. But at a really kind of low level, the computer is only doing one thing at a time, per CPU or per CPU core. It's only doing multiple things at a time when you start talking about multiple cores or various parallelism tricks. So this is one concept of performance. And I think what's interesting about this, what this picture is showing, was actually taken from a blog where that came out, I believe, earlier this week, actually, or late last week. And what happened is there was a developer that wanted to play some Grand Theft Auto 5. And so they had played it a couple years ago, and they found that just the load time was very, very long, right? Like, from clicking on the icon on their desktop to being in the game took multiple minutes. And in their mind, they were like, well, the performance is bad, right? Like, it shouldn't take 5, 6 minutes to load this game up, especially when the single player version of it takes much less time, especially when, loading into this from inside the single player portion of the game takes a very short amount of time. So what they did is they took the game apart, right? They started using disassemblers and they started using profilers and they started using all these performance optimization tools to understand what was actually happening in the game. And to make a long story short, when GTA 5 loads, it opens up a 65 megabyte JSON file that is downloaded from the internet. And then it parses that 65 megabyte JSON file in order to discover all of these different products essentially that can be bought inside the game using in-game currency. And the reason it was so poorly, reason it took so long is because it had a quadratic, the performance of the JSON parser that they wrote was quadratic and ran on a single thread. So it would literally take multiple minutes because it had the scanf function here would effectively every character would check the length of this entire 65 megabyte JSON file. And yeah, it takes a while because you're telling the computer, hey, scan through this whole thing. That's a type of performance problem, right? But what I want to point out is that performance problem didn't appear unbidden, right? No one theoretically came to this team and said, "Hey, you need to use this particular, hey, make the JSON parsing really slow." That probably wasn't a conversation that happened. I would guess. What seems far more likely is a bunch of game developers. Someone had a Jira ticket that's like, "Hey, we want to dynamically update this list of products on load, and we're going to do that by, this other team has built a service to, that is connected to some backend service that will create, a JSON file or a JSON blob, and then the client needs to read that JSON blob, right?" And maybe during testing and development, it wasn't a huge file. Maybe it was a megabyte. Maybe it was literally kilobytes, right? But over time, as this is a live game, a live service, that it keeps increasing in the amount of stuff in it, the amount of complexity, that file grew and grew and grew and grew, and now we are, years and years later, and it takes 4 minutes to parse that JSON file. Again, that wrinkle got there somehow. That parser got in there somehow, and I would suggest that it probably happened not because of a bug or because of maliciousness or incompetence. Even I would suggest that it's there because of people, right? Because when we build software, any kind of software, we're under all these constraints that exist because of the people that are building it, the people that are asking us to build it, the people we're building it for, right? We have timelines, we have all these human constructs, and that's what kind of makes me, a lot of people like to make this argument of like, what is building software like? So it's an art and a science, right? Like, it's not just an assembly line. It's not just, I mean, certainly the industry has tried this very assembly line, write really good specs for things and then hope it all works out style of programming before. They did this back in like the late 90s, the early to mid 2000s, right? If you've been in the industry a while, you might remember, UML and the idea that at some point very soon, building software is just going to be, hey, I'm going to have a bunch of people in the US writing these really complex diagrams and then shipping them off to someone overseas to code. And that didn't really work out the way that people thought it would. And I think the reason why we got to that point is because it's really, you need both. You can't just hand someone a document, a design document and say go. It's not a question of just like, I'm putting all these pre-assembled parts together. There is some art to it, right? There's teamwork, there's collaboration, there's all of these human factors that go into how we build and run our software. And that's why I say it's kind of like baking as opposed to any other kind of kitchen, because you need both, to be able to understand the science of what's going on, right? How all of your components fit together, how certain things work, right? Like you have these big tools that are sort of you're hanging your system off of, things like queues, Kafka, databases, managed APIs, storage endpoints, whatever, or even the underlying hardware or hardware abstractions like Kubernetes, right? And you've got all of these different things that you need to understand how they work, but you don't have to really understand exactly how they work, right? Like I don't need to understand if I'm making bread, I need to understand how yeast works on some high level, but I don't need to know the exact chemical composition and reaction. But sometimes I kind of need to understand a little bit more. Sometimes I need to understand a little bit less. It really depends on what I'm making and what I expect to get out of it. And when you're working, when you're baking as a team, right? Like when there's a difference between me going off and writing like a to-do app or writing, a piece of software for my own pleasure, and then maybe what you're doing or what we're doing to build products for companies. We're working together. It's not just about now you've taken that sort of art and science thing and you're expanding it out. You're saying like, okay, it's not just that I need to know this, it's that everyone else needs to know this, or we at least need to know what we need to know, and we need to know what we don't need to know. We need to be able to rank the relative importance of things. We need to be able to say, when there's a problem, how are we fixing this together? Who's working on what? And this is the difference between, I think, teams that build really high performing, high quality software and teams that don't, is that ability to work together, that ability to understand the process that delivers good software. It's the sort of team where someone's gonna be looking at things like, hey, when you're loading this JSON file, yeah, it's small right now, but what if it gets bigger? Now, some of us are fortunate enough to be in teams where we think about things like that, but most of us don't have that luxury simply because we're all weak and fallible humans, right? I don't have, and no one has perfect foresight. Why waste time on something if it might not matter? So what you need in that case is you need tools to help with these problems. You need tools to help you understand like where problems are, how are they presenting themselves sort of in real time and later on. So that's the techniques I want to talk about. These are the techniques and the kind of the tools that relate to them that actually do help you with this performance problem when you're trying to build and run software on a team, especially these days in our brave new distributed sort of environment. This is the sort of stuff that you need to think of. So the first one is continuous integration, right? And continuous integration is, hey, whenever I push code, I'm testing, right? And this doesn't necessarily mean, this is not a, oh, do more tests, right? I actually think a lot of unit tests are extremely low value, but the idea of CI is more about making sure that everything, and to me at least, is that when you're pushing code, you're pushing functioning code. You're pushing code that works. And I think what that really means is that you're always pushing to prod, right? Like you're always testing against the thing that is closest to production as you can, because you're never going to have like a staging environment or a demo environment or a test environment or whatever that mirrors prod closely enough to actually let you have the confidence that you need to develop very rapidly and ensure that your changes, especially changes from multiple different teams, are able to coexist together. So the thing that this leads to is stuff like feature flags, right? Like you need to be able to say, all right, team A and team B are going to be working on features in similar parts of the code. We need to use feature flags to make sure that no one's running into each other. And if you can do this, if you can have sort of that you're continuously integrating your changes and everyone else's changes, into upstream, into prod, then that's going to let you discover performance problems sooner, because now you're not using the 1 megabyte test file, you're using the live 65 megabyte, 100 megabyte, whatever, right? You're using something that looks a lot closer to what it's going to be at the end versus what it is, what someone thought it was. Because I know, and that a lot of times those staging environments, the demo environments, whatever, like they're prod like, but they're not like prod. And it's always a low priority to, narrow those two things. The second part of this, as you might guess, is continuous delivery, right? So much like you can't really know that your changes are going to work on prod until they're on prod and people are using them, the best way to ensure that is to make sure that you're constantly shipping to prod, right? I think continuous delivery gets a bad rap in a lot of cases. And I think a lot of the reason why is because people tend to think, oh, this means that you don't have staging at all, or you're not testing anything locally, or that you need to work out all these really complex sort of integration methods. I don't think it has to be that. I think really what it has to be is, yes, like being able to, every change goes into production immediately is probably not going to be viable for most people, especially people that have legacy systems. It's more about the journey to that point than it is actually achieving that point. So it's really about how can we reduce cycle time? How can we make smaller, more tightly scoped changes? How can we be responsive to change and changing demands so that we aren't in the situation where we aren't able to deliver that software? The tighter you get this loop, the better off you're going to be. And this is where I think the third technique comes in, and this is the one that really ties all this together, and that's continuous observability. Now, observability might be a word you're unfamiliar with. There's a lot of, if you go and you look on Twitter, you go and you look at a lot of different, companies, obviously Lightstep is an observability company, but there's a lot of other people that say they're observability companies. To put a fine point on it, observability is really two things in my mind. The first is pretty simple. It's you want to be able to ask arbitrary questions about your system. And what is an arbitrary question? Well, it's an arbitrary question. I know that's tautological, but the difference between like a traditional kind of monitoring, Nagios, what have you system and an observability system is that, there's a lot of predefined, there's a difference between like I get a predefined dashboard that tracks a lot of different things versus like Google, right? You can think of it really the difference between like when I want to go somewhere 20 years ago, well, let's say 30 years ago, makes the analogy work better. 30 years ago, if I wanted to go somewhere, I would need to go get an atlas, right? And that atlas would have all the roads on it, and it would let me, it would have all the roads, it would have parks, it would have, this and that and the other, and I would need to find where I was on that map, and I would need to find where I wanted to go, and then I would kind of need to trace, I would need to sit down and like say, okay, I need to go here, and then I need to take this interchange, I need to go over here, drive for 200 miles, and then get off there, and da 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 da. And I had very little context about that drive, right? Like when they printed that atlas, they printed it maybe even years or months before I actually took the trip. So it wasn't very responsive to change in the environment. It didn't know, where road work was. It didn't know necessarily where points of interest like gas stations or food was. Now, in 2021, if I take a trip, I go to, I take my phone, I plug in something into my Maps application, and now it's like, all right, turn by turn, I'm start here, go this far exactly. By the way, you should change lanes now. Oh, hey, do you need a gas station? There's like 40 billion of them right around you. Do you want McDonald's? Right over there. It does this because it has context, right? Because I'm looking at like live actual data about this system of roads that is trying to get me to a point, and it can use that context to give me a better answer. So instead of having to, for me to kind of do the work and know like, okay, I know I need to go here, 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 and I'm going to plot this out ahead of time and write it down. Now I can just have an arbitrary question like, hey, where's the next McDonald's? And my phone will tell me. Cool, right? How did we get that? We got that from context. And that's what continuous observability is really about. All of these things that I've been talking about, continuous integration, continuous delivery, feature flags, pushing to prod, there's concepts and techniques I didn't talk about, like chaos engineering, right? All of those are modifiers to the state of your system. And excuse me. What you need is this sort of context about your system that goes through the entire thing that can sort of let you ask these questions when something is happening rather than having to kind of know ahead of time what you want to watch out for. A good example of this is, let's go back, feature flags, right? I have a feature flag. I say, cool, here's my new API route. I think I've done some performance work on this, or I'm worried about the impact of this when I turn it on. So I'm going to put 20% of traffic through it. In a traditional sort of monitoring, traditional sort of like dashboard based monitoring where I had to go and pre-configure stuff, what happens, I see like the average latency went up on that endpoint. Why did it go up? Well, maybe I've added in some extra attributes and labels on my metrics, and now I can kind of see like A versus B. But what if I didn't do that? What if I didn't have those extra labels in order to split that data up? Because I don't know, that increases the cardinality, the complexity of that metric, and maybe that's something that my monitoring system can't handle. That can be a problem because now I see that I've spiked latency, but why? It could be because of that feature flag I just enabled for 20% of my users. But it could also be a million other things, right? And observability is about being able to take all those million other things, all those points of data, your application metrics, your infrastructure metrics, traces between your services, you know, data from your cloud provider about how long they, various metric points and traces and logs, and then stitching all that together and giving you sort of like a Google Maps across of it. You can just ask an arbitrary question of your observability system and say like, okay, hey, find the stuff, okay, cool. What's the 20% slowest stuff? Is that my new feature flag or is that something else? And this also goes into your CI and this also goes into your CD, right? So when you're pushing out changes, you can observe those changes in real time. You can see what's happening. When you're testing things and you're doing things, you're iterating, it gives you the ability to actually look at like, okay, well, we ran this, stress test yesterday and we ran it today. What's the difference? This is what observability lets you do. The second thing that observability kind of gives you, the second thing observability is about really, is about that teamwork I mentioned earlier. It's about, hey, how can I make sure that everyone on this team has this sort of same access to data and knows what's going on in the system? I don't want everyone to have to be an expert. I don't want every single person to have to be capable of like understanding everything going on. I want to let people just have access to this. I want to make it as easy as it is for me to pull up my phone and open up maps and go somewhere. So, how do you get observability? Well, there's a good part of this and a bad part of this, right? The good part about observability is it's actually not that hard when you get down to it. But it's not something you can buy either. I can sell it to you, but you can't buy it. Because observability is really three things. One, it's the cultural changes you need to make in order to do what I just talked about, right? Like it's about democratizing access to data. It's about making sure that you have standards and you have standard ways of kind of observing and monitoring systems. The rest of it, the other two parts, are about tools and frameworks. So observability tools are tools that help you analyze data, look at historical trends in that data, alert and graph those data points, do statistical analysis on them, and different teams are going to have different choices for this. Observability frameworks are things that actually collect the data. These should be very vendor neutral. You want everyone to use the same thing regardless of what observability tooling they're using. And this is what's generating the telemetry about your application and about your infrastructure. These provide standards and conventions that are crucial to be able to actually, get an observability practice going. One of those, or that framework I'm just talking about there, the one that I recommend right now is something called Open Telemetry. And we'll kind of roll right into the takeaways from this because I believe we're getting short on time. But the takeaways I want you to take away is one, you do want to have that same observability tooling, right? You want to have a single standard and you should use Open Telemetry for that. The second takeaway is I just gave you a lot of stuff, right? And maybe you're doing some of it, right? Maybe you're doing continuous integration. Maybe you're doing some level of continuous integration and continuous delivery. Maybe you're trying out observability, right? Like I hope you're here because you've heard something about it and you think like, oh, I should try this observability thing. You don't have to necessarily boil the ocean, even though it looks from the outside like you need to. You can actually get a lot of value by starting small, picking just a couple of services, picking things that are on the critical path. Observe those, right? Start to add in your your observability frameworks there, and then build out. There's a significant amount of value in starting small because it's easier to, not only to kind of get your feet wet and figure out what to do and what not to do, but it also helps build up that sort of cultural muscle of, okay, I need to get everyone to kind of buy in to this new way of thinking about things rather than kind of coming at the top and saying like, you need to, I'm going to go change how 100 people work. That tends to piss people off. But if you say like, okay, my team is going to adopt this and we're going to start, we have our 2 or 3 services that talk to each other. We're going to, you know, add in tracing and metrics and everything there, and then we're going to kind of shop that around to other people. The third thing that I think is a big takeaway here is that you want to actually observe everything you can. Now, you don't necessarily need to store all that data. 99% of your telemetry data from your application is honestly not worth keeping around. Certainly not in a raw form. Now, you should store aggregates about that data, right? And this is something that Lightstep helps you do, is we kind of take 100% of that data and then we only keep the parts that matter. But if you're trying to do this yourself, keep in mind, like, you don't need to store like full traces, full log history, things like that for a very long amount of time. You need to keep the interesting things. You need to keep sort of the aggregates around it so that you can go back and you can look month over month, quarter over quarter, year over year, what happened. But those details are usually not super interesting unless they are, and that's where you kind of get into a lot more complicated questions about like, well, what counts as interesting versus not. It's going to be different for different people. If you're a system that has, very high throughput, then maybe the individual data points aren't as important. If you have very low throughput, then maybe the converse is true, right? Like, you want more depth to what you're keeping there. So there's no one size fits all, I think is kind of what I'm trying to say. You need to think about this. It's not just it's not a thing where you just kind of go and you install some agents and you're done. There's a lot out there that helps you get to the starting line, or helps you kind of like get that over that initial hump. But then this is a process like anything else. It's not a product that you install and then you're done thinking about it forever. This is something that becomes part of how you're actually operating software at scale. So if you heard this and you say like, oh wow, that's cool, and you don't really know how this actually works in practice or what it would look like to use an observability tool, I want to encourage you to give Lightstep a shot. If you go to lightstep.com/sandbox, put in an email address. We have some really great, our engineers made like this really great sandbox tutorial that actually kind of walks you through how we think you should do it, right? How we think you should use observability tools. And it's a fun little game, and you can try it out with, just an email address. So give that a shot. And if you have any questions, we have plenty of time, I believe. So ask away.
Awesome. Thanks, Austin. That was great. So like Austin said, we're going to hop into our Q&A session here. Let's see here. I think to start off, Austin, I'm going to ask you a couple questions while people are entering their questions in the queue. So first off, where can people listen to your podcast? And also, are you going to speak at any other events this year?
Oh gosh, I have several. So if you want to follow me on Twitter, it's at Austin L. Parker. But that's where like my podcasts are linked to, stuff like that. So I have a couple different ones. I also I actually don't know how many places I'm speaking at right now, but I am there's 2 big events coming up. One is at the end of April. I'll be organizing Deserted Island DevOps, which, if you heard about last year, it was the DevOps conference in Animal Crossing. So we're doing that again. You can learn more about that at desertedislanddevops.com. The other thing coming up, I believe it's also in April, or it might be in May, is OlliFest. It's o11yfest.com, and that's going to be another virtual event that is all about observability, and we're going to have some fantastic talks from around sort of the observability and monitoring world. That's going to be, again, all virtual, and I o11yfest.com for that.
Awesome.
Both of those shows, actually, if you would like to speak at them, I believe have calls for papers still open until like middle of the month.
Cool. Very cool. We have a couple of questions in the queue here. The first one is, how do you get started with OpenTelemetry?
Yes. So maybe to even give a little more detail, OpenTelemetry, I didn't like super go into depth on it during the presentation, but OpenTelemetry is an observability framework. So it's the thing that actually generates telemetry about your application and infrastructure. And it does this through an API and an SDK. And then there's some tools like agents and things that can get host metrics and stuff like that for you. So the best way to get started with that is to check out the OpenTelemetry website at opentelemetry.io. All one word, opentelemetry.io. Depending on your language, you're going to actually install or use this in different ways. So let's say you've got like a Java application using Spring Boot or something. There's just a jar actually that you can download and then pass it into your application. You can add it to like your Maven build or whatever, and that will automatically instrument your Java application or your Java service with traces and metrics and things like that, and it'll plug into a bunch of popular libraries, things like Spring Boot, but also like JDBC for looking at database, SQL queries, things like that. If you're using other languages, like Python or Go, there's also automatic instrumentation options, or there's kind of integrations you can add in. So let's say you're using Go, you can import the net/HTTP instrumentation plugins, and then just add those as middleware to your existing HTTP routes, and that would trace incoming and outgoing, incoming HTTP connections to your service. So again, best place to get started is opentelemetry.io or the OpenTelemetry GitHub. So that's github.com/open-telemetry.
Sweet. We are running a little bit late on time, so I'm just going to ask one more question here. Is that also where you can, those places that you mentioned, is that also where you can find how OpenTelemetry works?
Yeah, there's some documentation there. There's also uh, actually Lightstep. We have a really good OpenTelemetry documentation site at opentelemetry.lightstep.com that goes into more of the concepts and how all this stuff works. So opentelemetry.lightstep.com. Check that out as well.
Very cool. All right. So yeah, that's all the time we have left for today. I want to thank Austin for presenting, and thank you all for joining us. Just as a reminder, you will receive a copy of this presentation. Other than that, I hope you have a wonderful rest of your day. And if you'd like any more